Hello everyone, welcome to the Sprint 48 Kiali and Jaeger summary and demos November 28th. Today we will have several speakers. It's quite nice, because we will have Alberto, Joel, Xavi, and Yuka from the Jaeger team to present summaries of what we have done on these 3 weeks and some demos of the features that we have. So, as always, thank you for all the community. Thank you for all the feedback. All that we have done in the Sprint 48 is public. We use in the Kiali project, we use GitHub projects as a Kanban way to see what we have in the backlog, what are the big epics that we are working on, what is in progress, what are the pull requests, what is merged, what is done. Okay, so I would like just also to remind that have some question in Slack about how to collaborate, how to contribute in the project, and it's quite easy, and we love contribution in several ways. So if you want to report issues, or you want to request new features, or to start some discussion on something interesting, some integration that you want, just talk with us. So there are several channels when you can contact with the Kiali team. We have 2 mailing lists as well. We use the IRC, the strong IRC channel in Freenode in the Kiali. That's always 24 hours open. But we are also modern, and we are also in Slack, in Istio Slack in the Kiali room, and also in the discuss.istio.io. There is a flag for Kiali discussion that we also track from that. So some of the Sprint 48 highlights that we have in this summary. So most of the work, the hard work, was done in bug fixing, performance aspect, refactoring of the work in the UI, backend, operator, the chart library. So if you go to the Kiali issues and check what is closed in the project, you will see all the types of things, right? But if we want to show some of the more visual enhancements that you will see in the Kiali 1.28, so we will have some UI improvements to some alignment in all the headers across all the pages, so all the time controllers are located in the same place across all the navigation, just to have a better consistency to all the pages between them. In the previous, the overview was quite different from others, so we try to normalize that. Another of the improvement that we have also for performance reason is that now we have changed in the namespace selector. So we have explicit select all. Also, we have improved the batch behavior. So this means when we are selecting namespaces, it finishes that is wait until you finish to select your namespace to perform the query. So it's not just fetching just when you click. So that is going to improve the performance of the graph and all the pages. And also the same selection is seen across the graph and the list pages. So in the list pages, by default, when no selections was understood like select all, but now that we have a explicit select all, when you have no selection, the list pages are going to show empty. Also, another improvement that we have is in the Warlord details. We have a Warlord spot with the status of every pod, that this information of the status of every pod has been augmented, improved, also to show more information, specifically in the evicted situation, when some pod is evicted in the phases, so you will have a tooltip with more explicit, specific info for that, right? And I'm going to pass the mic to my colleague Alberto, who is going to tell you the news and the work in progress about the configuration. So I'm going to stop sharing.
Okay. Can you see my screen?
Yeah.
Okay, so in a previous sprint demo, we talked about the health configuration in Kiali, and now we want to show you a quick demo and some improvements that we are going to release soon related with that. As you know, Kiali allows us to configure the health of the CR, letting us change when a resource is degraded or failure in our environment, based on the error codes. In this demo that you are seeing, we deployed the Kiali demos error rates example, So we have the namespace beta and alpha. And for example, both namespace have the same design and the same error code responses. And in this namespace particularly, we can see that the EU server is in a failure status because it's returning 404 error codes. The way server is returning 500 error codes. And for example, the X server is returning 401 error codes. This namespace is applying the default configuration for Kiali that is fetching the 400, 500 error codes. And this is why we are seeing that with a failure status. If we move to the alpha namespace, we can see that some status changed because we applied a specific configuration for all the resources in namespace alpha for a failure status with 40% for all 400 error codes except 504 error codes. So the WU server is now healthy status because we are ignoring this 404 error code. The Y server is in the ready status because the error rate is lower than the 40% that we configured. If we check the U server, we can see that the percent error is 80%. And the X server is still in failure status because this one is returning 401 error code. And the error rate is greater than 40%, 45 in this case. Well, this is great to customize the health in our namespace, but what happens if we need to adjust the health for one resource in one moment? Do we need to change the CR for this? Okay, so now we did a new improvement that you can configure the health via resource dynamically via annotations. For example, the X server is returning a 4,500% of error rates with the response code 401. And we want to avoid this kind of error because maybe it's not related with my business or the client authentication. There is a client authentication problem not related with the service, etc. So we only need to set a annotation to this resource to fix that. So can you see my terminal?
Yeah.
Okay, so you can see that the syntax is so similar to the CR file. We only need to add the tolerance syntax to these resources. So we are going to add this tolerance to the X server service to avoid the 401 error codes. Okay. Okay, we can see that now the X server is in a health status. Okay, this is an easy way to make this change in one moment dynamically and without changing the CR file. If we go to the service list, we can also see that there is a Kiali annotation applied for the resources. If this Kiali annotation is grown, Kiali is going to advise us. And if it's grown or in a bad format, Kiali is going to ignore it and is going to apply the configuration that Kiali will found in the CR file. The next step that we are working is enable modifying this kind of objects of Kiali as we do with the Istio configuration wizard to improve the user experience with this kind of objects. We hope to have it for the next release. And yeah, I think that this is all about the health configuration. So I will give you the mic back and thank you.
Thank you, Alberto. Pretty nice features. So this one I think is going to be Joel. So Joel is going to tell us about the new improvements in the tracing correlation with the telemetry metrics. So Joel, so feel free to share your screen and start your demo.
Hello. So you should be able to see my screen. So I have a Kiali console here shared.
Yeah.
So this is the tracing page that we can find in any workload or application or service details in Kiali. And we have improved here the list of the span details. So you know that when you select a trace on that screen, you can have some trace details here and some spans details. And we have added new statistics here that are based on correlations with metrics between span duration, which is the request duration for every span, and the metrics that we are able to find matching this same kind of elements. So, for instance, here I have, you can see that I have several spans. I have a lot of span here, 45 spans in that trace. And for some of them, I can see that there is a heat map that shows up here. Some of the others don't. The one with the heat maps are spans that are provided by the Envoy sidecar. So they are annotated here with component proxy. So here I'm just going to filter them. Component show all the proxy components. So I can have only spans with the statistics, with the heat map. And what this heat map is for every span, so for every request, is a comparison with similar metrics. If I click on a heat map here, I see some details. It's a comparison map that shows a matrix of request duration compared to duration from metrics aggregated over time. So this is a traces and matrix correlation that we are able to do thanks for the consistency of traces and matrix due to the Envoy sidecar. So this is what allows us to do that. And here, if I pass the mouse over the different cells, I can have the details. If you don't, at the first sight, if you don't really understand what these numbers here, you can have the details here. For instance, we can see here that the request has been like less than 1 millisecond slower than the average of all inbound requests from the same workload in the last 60 minutes. And I have, in the same way, the median, the 90 percentile and 99 percentile. And with this, we can quite easily find spans that have a bad duration, like that behave badly compared to similar metrics. So for instance, I can see that this one is a lot slower than usual. And this is interesting to have this visual information very quickly. So you can quickly spot the problems, and you can also troubleshoot here. For instance, if I see that I have these two red heat maps, one is coming from a workload ball sent to the stadium, and this is the corresponding span on the other side. So this is the client call, and this is the server reception of the request. So what does it mean if I have both of them being red? It means that basically the problem lies on the stadium side, and it's not likely a network connectivity issue or something like this. It's more problem in the stadium side because it was very, it took a lot of time to respond, to provide its response. So if I'm troubleshooting that, probably I'm going there to go here and find the logs for this workload. So this is basically it. The compact view here shows the same information, same kind of information as the expanded view. When I click here, I have the expanded view, but I still have the same tooltips here that can provide me some help about what it is exactly. And yeah, that is all for my side. Thank you.
Thank you a lot, Joel. Very interesting feature to show. So next, in today's sprint demo summary, we are going to have Xavi that is going to tell us about the working progress of the improvement, also to bring in Kiali more details about the proxies, about the Envoy information that we can use for troubleshooting a scenario. So Xavi, feel free to share your screen.
Sharing my screen. Okay, do you see the slides, the slide deck?
Yes.
Cool. So yeah, before going to the proxy information, let me add here a little bit enhancements.
that we've done, especially in the Istio component status. This Istio component status, it was a really useful tool for admins or operators to understand the key components of Istio, which ones were doing bad or not that good, and that may affect on the whole performance of your mesh. Right now, we extend a little bit the way to check the components, especially for Prometheus, Grafana, and Jaeger, and we no longer check the deployment status. We don't check for how those services are deployed, but we check for connectivity to those components. This way, we are able to cover more scenarios of how you deploy those three add-ons, because maybe Prometheus is not even in your cluster, maybe it's outside or in different namespaces, or instead of using deployment, you use the Prometheus operator or different one, right? So we open this to cover more scenarios. And now regarding to the envoy config, so this is really important, right? Envoy config is in front of every workload in the mesh. We have for a workload in front, we have this proxy, the envoy proxy. So this is really crucial for the service mesh to go in the data plane. Every request flows from one proxy to the other, right? So what we've done is, and from the point of Kiali, which is easing the task for you to understand what happened in the mesh, what we've done is like we brought the envoy config to Kiali. How it is? So what we've done is, like, if you go to the workload, since the proxy is at pod level, so we go to workloads where mostly are the pods and the workloads there. And also in the detail page, we can see that we have here 2 pods, and for each pod, what we have is the Istio container, the proxy, right? I'm using the 1.8 alpha 2 version of it. And now for details v1, I'd like to know how is the configuration in this envoy, because it's not always really easy, and always it's not that straightforward to use Istio, and sometimes there's some unsync scenarios where the pilot has some information but your proxy has a different one, right? So if you go to the Kiali actions, we have add one more option here, which is the envoy config. With that, what we do is we show, this is really the first step. What we show is the raw configuration for each pod. So it's the envoy config where you can see the static clusters, also the dynamic ones, listeners, the same, the static and dynamic ones. So we are using the discovery service from the envoy to discover the routes, the listeners, the clusters, the secrets, right? So you have also the routes, the inbound to 9080, it goes without a prefix to some place, right? So this is a handy way for you to debug a scenario where you have some problems, and especially you don't have to go to the client anymore, to the IstioCTL, to fetch this information. But this is a first step, and this is kind of raw information, right? It's kind of, you need to understand with a lot of knowledge. You need to understand, you need to go and dig deeper into it to understand it, right? So what also we want to achieve is we want to digest this raw information and show it in a more digested way. This is still a work in progress now, but now what you can see, it's like we digest a little bit the information of the clusters. So you see that there's one for the Giga collector, there's another one for Kiali, for MongoDB in Bookinfo, all right, and the same for routes. So with this, the idea is to give like highlight information for you to troubleshoot a specific scenarios, and also because the envoy configuration that might be wrong. Maybe you got a bug from Istio, or maybe there was a glitch on the synchronization between pilot and the other. And again, this is not going to be shipped in this version, but is a work in progress. And yeah, the idea is to collect feedback and to like hear from you what you think about it. And somehow what we are gonna have is something similar to the istio-ctl proxy config command in a but print in a UI, and without you have to worry about all the parameters and so on. And yeah, I think that's it from my side.
Okay, so thank you, Xavi, a lot. Amazing features. So I'm going to share my screen because we are going to have Shuka just giving an update for the Jaeger and OpenTelemetry highlights on the Jaeger team. And Shuka, so you have the mic.
Sure, thank you. So yeah, on the OpenTelemetry front, we had a new metric added to the Java SDK with a gauge for the queue size. On the collector, we had a couple of things. So two of them are just catching up with the latest APIs, and one is a bug fix. And the second item here in this list, the load balancer exporter, it is something that took a while to get merged, and it's part of the demo that I'm running in a couple of minutes. And on the Jaeger side, yeah, we had a bug when we had a bug that the ES operator was upgrading when multiple Jaeger instances were being used with the same name but on different namespaces. We had a clash there, a problem when the upgrade rolled there, so we fixed that. We also added a support for tolerations on the auto-provisioned Elasticsearch cluster. So people can now specify on the Jaeger CR the tolerations for the provisioned ES Elasticsearch. And we got one issue done by Ruben, and was really cool. The community was waiting for a way of improving the way that the Jaeger shows a trace when there are a large number of spans, and I think that was really cool. All right, so if you could move to the next slide, Lucas. Yeah, so for the load balancer exporter demo, so this load balancer is one of the missing pieces to a scalable tail-based sampling. So for tail-based sampling to happen, we need all the spans for a given trace land at the same OpenTelemetry collector instance. Right, so so that we can then make a decision on whether or not to sample that trace. Now, that works well when we have only one instance of the OpenTelemetry collector, but if we have multiple instances, then there was no way to guarantee that all the spans for the same trace would land at the same instance. And that's what this load balancer then is doing. So the load balancer basically implements a classic consistent hash ring. And what it does, it places or it calculates the place in the ring for a specific trace ID. Let's say that one trace ID is on the very left-hand side here on this image on the load balancer, the first arrow. So it says that it's on that angle of the circle. And then what the load balancer does is it looks for what is the next collector from that point in the ring. Right, and then we move, and then you can see that we have two arrows here pointing to the same collector, and then the third arrow here is at around, I don't know, 15 degrees, and then it says that the collector for that trace ID is then the OpenTelemetry collector 2. So this allows us to increase or decrease the number of OpenTelemetry collectors with minimal disruption to the ring. You can go to the next slide, Lucas, please. So in this case here, we added a new collector backend, and that affected only one of those trace IDs, right? So only the very first trace ID, or only the first arrow here, has a new collector, so the disruption to the ring is minimal. Now, this is opposed to doing a regular hash mod n, which is typically the case for this kind of scenario, but that doesn't works well with a elastic number of backends, right? So if you do a mod hash n, then for every new host or every host that disappears, then all the trace ID or all the range there is moved. So it affects pretty much all the trace IDs. In our case here, it affects only 1/n of the trace ID range. All right, so I'm now going to share my screen and see how that works in practice. So you should be seeing now my terminal. And in one window here, I have the OpenTelemetry. Yep.
Yeah, we can see.
Okay.
Yeah.
In one window here, in one terminal, you can see the OpenTelemetry contrib collector that I'm going to start. But first, I'm going to start Jaeger, so the all-in-one. That was fast. All-in-one with a max memory, maximum number of traces in memory for 10,000, just not to overload my machine. And then I start the OpenTelemetry contrib collector. OpenTelemetry contrib collector, right, with this configuration that I'm going to show you in a few moments. And I'm going to generate some traces in 5 seconds. Now, while that 5 seconds elapses, I'm going to show you the configuration for my OpenTelemetry collector, so it's completed. What I have here is one receiver that represents the load balancer, and then one receiver for each backend that I have here. So you can see that they're all on different ports. And ideally, in the real world, each backend would be on its own node, process, pod, host, or, so there are different processes. In this case here for testing, it's on the same binary on the same process. And then on the exporter side, I specify what is the final destination for all the spans. In this case here, it's only one Jaeger, and that's it. And we specify the load balancing exporter, and that is what was done during this sprint here. We specify what are the host the host names, or the backends that are going to receive the spans from the load balancer, and then here we specify the pipelines. Those here matches they match here. What we've specified here in the receivers, right? So 55690. Yep.
Sorry, the config isn't showing. It's your console that's showing.
Oh, I'm sorry. Let me show my browser then. I'm sorry. I want to. Yeah, this one here. Okay, so you should now be seeing GitHub. With a gist with my config. Okay, I'm sorry. So yeah, I probably should go over here just quickly again. So the first receiver here is the load balancer. So this is the one that is at the very beginning of the process, and then here each one of those 4 backends that I'm configuring, and then on the exporter side, I have the final destination. So this is Jaeger, and the configuration for the load balancing exporter. And then I say that I have here 4 backends for the exporter, so 55690 matching the 55690 here. And then the pipelines, so it always starts with the load balancer and then goes through no processors at all, and then goes to the load balancing exporter. And then each backend has its own receiver or pipeline. So the pipeline for the backend 1, so the receiver backend 1, and then it goes to Jaeger. All right. So in the other window, I started the OpenTelemetry collector process, and I started Jaeger, and I ran the trace generator, generating some spans, some traces, and I cannot think of any other way of showing you how it works than just showing the metrics. Just refreshed here. so that we can see what's going on here. So we see that we have a set of metrics for the load balancer, and we see that each bucket or each endpoint, so we see that this endpoint here received 8,000 spans, the next one received almost 10,000 spans, then 8.7 and 8.2. So we see that it's balancing, not round robin, so it's expected to be some difference, but they are on the same ballpark here. And then we see a summary here as well. But more importantly, we can see that we have around 70,000 spans being received by the load balancer. And here on the Jaeger matrix, we should have the same number, so 7656, and that's what we have here as well. All right, so on Jaeger side. That's pretty much it for the demo. So with this exporter, I think we now have all the pieces to achieve a scalable tail-based sampling solution for OpenTelemetry collector. Now it's back to you, Lucas.
Okay, so thank you, Yuka, for showing the updates and for the nice demo, for all the scalability issues that are quite interesting to see what is going on. So yeah, I guess that is more for the session. What I'm going to do now is stop the recording. Just to open